There is a process for approximating square roots that's called Newton's method. And I'm going to show you how this works by using it to calculate an approximation for the square root of 2. You start by graphing the equation x squared minus whatever it is you're trying to take the square root of, which in this case is x squared minus 2. And the thing to notice here is that the x-intercept here on the right, 0 equals x squared minus 2, 2 equals x squared, would be the square root of 2. So this x-intercept is square root of 2 comma 0. And we want to find an approximation for that. So the way that works is that we start with a guess. And I like to pick the number, since the square root of 2 is between 1 and 2, I like to use the number that's kind of a little bigger than the square root. If I was doing the square root of 25, square root of 24, sorry, I might use 5 as my first guess. I like to use the number that's slightly bigger than the square root, the integer that's slightly bigger than it. And I'm going to locate the point on the parabola that has x coordinate of that guess. And since this equation is y equals x squared minus 2, the y value will be 2 squared minus 2, which is 2 also. Now, I make the tangent line at that point, and the x-coordinate of this tangent line, because the way the slope is positive, the x-coordinate of the tangent line is going to be a little bit to the left of the initial point. But it's not going to be to the left of the intercept, otherwise it wouldn't be a tangent line because it would cross the parabola again. And if I could find this x-coordinate, it will be closer to the actual square root than the initial guess. Well, there's something called point-slope form. Y minus y1 equals m times x minus x1. So we know that the point is 2 comma 2, so I put a 2 here and a 2 here. Now the slope, in a previous video, I showed that in a parabola, y equals x squared plus or minus something will always be double the x-coordinate. So if I double this 2, 2 times 2 is 4, that becomes my slope. That's the slope of this tangent line. And if I plug 0 in for y, of course any x-intercept has 0 as its y-intercept. Equals 3 over 2. So this is my next approximation, and it is the x-coordinate of that point. So I now have a better guess. It's about 1.5. It is 1.5. It's closer to the square root. But now I can do the process again by using this new guess and sort of moving upward to find the point on the parabola whose x-coordinate is this new value. So it's like this. So this point is 3 over 2. The parabola is y equals x squared minus 2, so it's 3 over 2 squared minus 2, which is 9 over 4, minus 2, which is 9 over 4, minus 8 over 4 is 1/4. So 3 over 2 comma 1/4 is the point. This tangent line has an equation y minus 1/4 equals the slope times x minus 3/2. The slope is double the x-coordinate, double 3/2 is 3. And now by putting 0 in for y, and solving, add 9/2 to both sides. (18 over 4) equals 17 over 4. That's 3x. Divide both sides by 3. Just go like that. X equals 17 over 12. That's going to be our A2. 17 over 12 is a very good approximation. That's the x-coordinate of this point. 17. That's 17 over 12, comma 0. And if you're really feeling ambitious, you take this 17 over 12, comma 0, and use it as your new guess, and find the slope of this tangent line, and the x-intercept of that tangent line will be an even better guess. Well, this point here has an x-coordinate of 17 over 12, but its y-coordinate, this was x squared minus 2. So the y-coordinate, 289 over 144, 2 is 288 over 144, is 1 over 144. So the equation of this blue tangent line is y minus 1 over 144 equals the slope. Well, the slope is double the x-coordinate. Double 17 over 12 is 17 over 6. We want our goal is to get the x-intercept, so we plug 0 in for y. We get minus 1 over 144 equals 17 over 6 times x minus 17 over 12. Personally, I'd multiply both sides by 6 to cancel these out. And 6, I'll just leave it. Minus 6 over 144 is equal to 17x minus 289 over 12. Add the 289 over 12 to both sides. I'm going to multiply, get a common denominator of 144. So that 289 gets pretty big now. It's 3468. That equals 17x. 3462 over 144 equals 17x. When you divide both sides by 17, let's move to the little bit of free space we have right here. Divide both sides by 17, get 3462 over 2,448. That happens to reduce to 577 over 408. And if you type that into a calculator, you will see something extremely close to the square root 2. So that's how the Newton method works for square roots.